Hello, everybody. We're live here at Accelerate, and with me today I have Stephen Mallette, who I don't actually know Stephen's real title, but I'm just going to say you're the you're graph developer extraordinaire.
Okay,
that's
fair
how
enough.
I know you.
That is fair enough.
So anyway.
From DataStax, this is the Distributed Data Show.
We're going to talk today, let's see, about some of the new things that are coming with Tinkerpop, and then you also had a talk that you did here at Accelerate. From what was it? From novice to advanced,
Yes, novice to advanced Gremlin usage. I wanted to try to express to people how to get there, and then we talked a little bit about, once you do get there, how you build applications with Gremlin domain-specific languages. Something you and I have talked about before in the past.
Yeah. No, we talked about DSLs a long time ago, and now it's time to revisit a little bit and kind of see what's going on there. So, all right, let's talk about Tinkerpop. What's going on with Tinkerpop?
For some time now, we've been working on the latest version of Tinkerpop, latest major version, which is 3.4. And I think a lot of folks may not know how we version things in Tinkerpop. We actually divide the major versions in Tinkerpop into sort of like eras of thinking, which is sort of our version, our rendition of semantic versioning.
Okay.
So when we have a major version, we're typically talking about sort of major rewrites of everything. And for version 3, Tinkerpop 3, which is everyone's been using for many years now, that's been kind of the longest era at this point.
What was in that era? Like, what did that signify? Because if I understand what you're saying, so like version 1 would have been a particular era. Yeah. Version 2 would have been another era. So what is version 3? What does that era mean?
Yeah, I think version 3 was about doing something that we'd always swore we'd never do in previous versions. We decided we wanted to branch out of just being in the JVM. We wanted to get onto other programming language ecosystems. We wanted to get into Python. We wanted to get into JavaScript. We wanted to get into .NET and really anywhere else that we might think developers could make use of Graph and make use of the Tinkerpop ecosystem.
Okay.
So once we embrace that, we've seen a lot of new contributions in the Apache Tinkerpop community.
Oh, that's cool. You got all those different language variants right now that you cover. So you're going to get more people who are going to be able to get into it.
Exactly. And I think that's been really helpful for folks because being able to support all these languages as first-class systems in Tinkerpop made it a little bit easier for companies and people to choose to use it in the first place. Because when it's officially supported by the project and it's officially part of the ecosystem, you feel a little bit more comfortable rather than having to kind of pick and choose and figure out if something is going to really work.
Right.
Is somebody really supporting it? So this really seemed to open up the floodgates for letting people come in and start using from all these different languages. And I think we've learned a lot in the process because we're getting feedback from sort of different different developer experiences, and different tooling that they use in those places. So that's been really helpful. So that was kind of what Tinkerpop 3 was the Tinkerpop 3 era was all about.
Okay, so we're still in era 3.
Yep.
Right now we're at 3.4.
Yep. Okay. So 0.4, the sort of the minor revision is typically our major revisions. That's when we think about breaking changes. That's when we think about changes in behavior.
Did you break it all?
Actually,
did I just hit on something?
Actually, going from 3 to 4, going from 3 to 4, 0.3 to 0.4, we really didn't have a whole ton of major breaking things. It happens sometimes. It doesn't happen all the time. So those major changes in behavior are on the table at least.
Okay.
So we'll introduce sometimes features that might be experimental as well, that become and have a deprecation path that allow us to then in the future on that next major revision kill out all that deprecation, and you have you at least have this easy way to kind of move on to the next version. So we try to be nice about those things. That's also sort of a fundamental part of the era 3 version.
Yeah.
In 2, you had no such guarantees. We would just we break it, and there was not much we really wouldn't care all that much, to be honest.
So I'm glad that you guys decided to change your mind.
We got smarter. We got a little smarter.
Made it nicer on the people coding with that.
Yeah, we got a little bit smarter. So we spent a lot of time on 3.4, and then the patch revisions are just pretty much that in Tinkerpop. We try to have no breaking changes in those patch revisions, and just do bug fixes and maybe some light new feature introductions. But that's kind of how our versioning tends to work. So we did spend a lot of time on 3.4. Spent almost a year on it in 2018.
Oh, wow.
It released right at the beginning of the year.
Oh, okay. That was going to be my next question. So this is already out for consumption, open source, Tinkerpop 3.4, all that.
Yeah, absolutely. Absolutely. We actually released we went to a faster release cadence after that long wait. We've been doing releases every 2 months. So we did release one 3.41 already a couple months ago. And as soon as I leave Accelerate, I'll be working on releasing 3.42, and that'll be out the door as well, as well as the 3.3 line. We still maintain that as well. So with 3.4, we came up with some neat new features. One of the things we really tried to focus on was developing parity across the different language variants. It used to be that you had a fair bit of difference potentially between the Java experience and say the JavaScript experience. So we tried to bring all those things a little bit closer together. And I think we managed to accomplish that in many ways. It involved a lot of rewrite to our documentation. But I think overall the user experience is a whole lot nicer.
It sounds like that would apply really well to cases where maybe you have an enterprise, and in the enterprise you have multiple languages where you need to support Graph or for Gremlin and that kind of deal. And then I would think that the experience between the developers working on those, if you have someone going from an application here in C#, one going here in a JavaScript or something like that, that now they're going to have a more I almost said unique, but the exact opposite of that. But they're going to have a more a regular experience. Like I can go into one language and I can use the same traversal that I would use in another language and another language. So it's uniform. Is what I was looking for.
It's uniform in terms of how you connect. It's more uniform in terms of how results come back from the system. You're not getting a whole lot of disparity there.
That's cool.
Anymore. So we worked really hard to do that. Part of that effort made us realize too that we needed a better serialization format for Graph, at least from a network serialization perspective. And so we've introduced something called Graph Binary, which is really the third network serialization format. We started out with two. We had Gryo, which was a cryo-based serialization format, but it was very much bound to the JVM, which doesn't really work too well if you have all these other language variants, right? If you're in Python and you can't use it, it's not useful. It was super fast. I really do like Cryo, but it is definitely something that works really well only on the JVM. The second serialization format we had was GraphSon, which was JSON based. And that worked very well across all the different language variants. But the issue we found with that is we couldn't quite ever achieve complete parity in terms of speed and performance with Gryo. So then again, here was a situation where you had different performance characteristics in Java versus the other. So we got pretty close, but even still, it still wasn't quite there. You also had the issue of Gryo being a binary format, had much smaller network serialization payload sizes. And so with GraphSon, I mean, you could turn on some kind of zip function or something like that to compress the data a little bit. But even still, you had a fairly large payload. And so we wanted to reduce those payload sizes. So Graph Binary we kind of decided that Graph Binary would be our own serialization format that was optimized specifically for Graph, for network serialization, for what Tinkerpop was doing with all these different languages, was going to be really what we needed.
So that sounds like to me then with Graph Binary that you can say more guarantee the same experience, like performance characteristics and such across the different languages. Do I have that right?
That's what we're shooting for. We definitely have that now on the server side. We've kind of released it in an experimental form, mostly in 3.4. I think by 3.5 we would like to have that out and available for all the different language variants. We've been trying to solicit feedback from the community about Graph Binary and what they're finding in usage with Java.
So right there, that's a call to action for all those watching right now, right? Let's solicit some feedback, right? We want to have you take a look at Tinkerpop 3.4, Graph Binaries, Give us your feedback. How do they do that, by the way? How would they give you feedback?
The Gremlin users mailing list, it's a great way to do that. The dev list, if you're so inclined to get involved on there, the dev list is a great place to do that as well. But both of those places would be interested in hearing what folks have to say about it.
Okay, so then we've got the graph binary piece, right? What else is coming with 3.4? Is that like the major thing, or?
Yeah, graph binary is a major thing. Another thing would be the what we call the I/O step.
Okay.
It's a new step in Gremlin, and what it enables you to do is, this goes back to having parity across languages.
Yeah.
Prior to 3.4, you didn't have a way in which to load a graph file. So a GraphML type file or a GraphSon file. You really didn't have a way to do that if you were in JavaScript or in or any other language besides Java, or if you were just sending scripts to the server. You could do it if you sent a script, but that's technically, that's not really how we want things to work. We want people to write Gremlin in their language, natively in their environment.
Right.
And so the I/O step kind of made I/O essentially a first-class citizen in the Gremlin language itself.
Okay. And
that enables everyone to have the same kind of experience for loading data. And what's really nice, I think, for graph databases and graph systems that support Tinkerpop, they can basically override, just like they can override any step in Gremlin. They can override that default behavior that we have, which is really simple. It's just a single-threaded load of whatever graph file you give it.
Okay.
But they can overload that behavior with their native bulk loading systems.
Oh, that's cool.
Right. So now, if you're such a system that has a way to, say, bulk load or parallel load data into your graph, you can now use this I/O step to expose that in a Gremlin fashion, in a unified fashion, in a way that any programming language can utilize it.
Okay.
And I think most native bulk loaders that I've seen from the graphs I know about, they tend to be very specific to whatever programming language they're written in, right?
Okay,
like they're going to be a Java-based thing, and they're only going to be able to do it in Java.
Right.
Now you have some options as to what.
And so the I/O step then again is across all of the language variants that are supported for Tinkerpop, and then hence Gremlin and that kind of deal.
Exactly.
So that means you have that capability. Anyone in the supported language variants, they not only have now the graph binary capability, but they also have the I/O step.
Yes.
That's cool.
Yep. So those are some of the key things with 3.4.
Okay.
We definitely added a lot of other odds and ends and improvements and a bunch of bug fixes along the way.
Yeah.
Especially accumulated from multiple releases we had from 3.3, which kind of merged their way up.
Right.
So we had a lot of good things there.
Okay, that's cool. Now, I don't know if you can answer this, but it sounds like you're already working on the next stuff, right?
Yep.
Is there any kind of view you can give us into what's coming? Or, I mean, if you can, I get it.
I mean, these are all my thoughts. We haven't had a ton of discussion in the community yet as to what's going to come in 3.5.
Okay.
Because we're going to be starting 3.5 development next week, basically.
Yeah.
And we'll be opening up that branch. So, now's a great time for folks to tell us, what kinds of things they want to have, what kinds of changes of behavior you guys want to have.
There you go.
And now's the time that can happen.
Cool.
So
call to action. That's right. Do what Steven says. Give us the feedback for 3.5.
So I think I mentioned earlier, we'd like to see graph binary be like the primary way in which folks are doing their network serialization and connecting to the graph. So we'll probably kind of push Gryo and GraphSon back a little bit. Maybe it won't be part of the default configurations anymore.
So you'll lead with graph binary. Those other things will kind of be
They'll
there.
still be there.
You'll
just have to you'll have to reconfigure them in yourself.
Now, with graph binary, I mean, other than making, again, the performance characteristics more uniform across the different languages, did you see a performance increase with binary now? Yeah,
graph binary was, in our comparisons, much faster.
Okay.
Then I couldn't give exact numbers off the top of my head, but we definitely saw a massive increase in performance. So that's a really neat thing, because it just means by changing a configuration, we suddenly get this nice bounce in all traversals that we have.
That's cool.
That's a really
neat. That's actually really exciting. Yeah. And we were talking before a little bit that, so if we look at DataStax Enterprise Graph for a moment, That is currently what in the latest versions using 3.3.
Yeah,
right?
6.7,
6.7 DSE 6.7 using 3.3. So where does 3.4 come into play?
3.4 will come with 6.8.
Okay.
And things
Okay.
forward from there.
Okay.
So yeah, we should hopefully start to see those kind of benefits coming through on 6.8 for sure.
Okay, and I'm wondering too if there's kind of a added benefit, because if you think about the changes that came out in DSE 6, right, especially with advanced performance, thread per core, storage engine optimization, there were some pretty significant bumps we got in DSE graph.
Right.
And then it sounds like then as we move into the future with binary alone, right, and then adding on top of that, we can expect some more.
Yeah,
is what it feels like.
Yeah, absolutely.
Okay.
That's the way it sounds like to me. So
Okay.
we'll wait and see what all the benchmarks add up to. But
Okay.
yeah, I like the chances of seeing that just by changing that configuration.
Yeah, that's awesome. I'm like, all right, cool. I gotta check this out. So you did your talk. You did a talk at Accelerate here, and I want to say it was on like going from novice to advanced with Graph and Tinkerpop and that kind of deal. Can you tell us?
Yeah.
Tell us about the talk. What did you talk
Absolutely.
about?
So we had I've had a lot of time to think about. For a long time, I've thought about what it takes to go from being a novice to an advanced Gremlin user.
Yeah.
And a lot of people think it's like this really wide gap that you have to get over. And I've kind of distilled it down after helping I don't know how many hundreds of people on the internet.
Yeah.
And Stack Overflow and Gremlin users and just talking to people here at Accelerate. It seems like it boils down to one thing. Most people really understand it. In 2 hours to 2 days, most people understand three basic things in Gremlin. They understand basic filtering.
Okay.
How do I find that initial set of vertices that I traverse from?
Okay.
And then the second thing they understand is the navigational perspective, right? Graphs are very intuitive because they're pretty much just moving in and out from one vertex to another, following lines,
Right.
And so that's a very kind of intuitive thing to write your queries in, right? And especially since Gremlin matches that intuitive movement.
Okay.
That's why we call things traversals instead of queries, right?
Right.
We're trying to convey
across those
trying to
lines,
convey
right.
that notion of movement.
Okay.
And so most people understand how to traverse extraordinarily deep paths in their graphs.
Right.
And then the next thing that people understand is simple transformations.
Okay.
They understand how to pull data out of the vertices they find.
Right.
They understand how to do counts, ordering data. Those are very similar to SQL type constructs. And so folks get that.
Okay.
But then the issue of moving from novice to advanced, and by the way, not to knock novice, but you can get a lot done as
Yeah,
novice.
I'm actually curious. I mean, you just kind of laid out these three different areas that would probably cover the novice, but I'm actually curious, where, in your mind, what determines the novice compared to advanced, right?
Yeah, it's wild. You can actually, I was looking at the steps I kind of consider maybe the ones, again, that people get 2 hours to 2 days. And strung together correctly, I mean, you can write a rudimentary recommendation algorithm with just novice knowledge of Gremlin. And again, that's to me, that's a 2 hours to 2 days kind of thing.
Okay.
And again, just rudimentary, pretty simple stuff. But once you get that, building upon that is actually pretty straightforward, even from the novice perspective. So, and certainly from an analysis perspective, right? If you're just analyzing the graph, you're trying to walk some paths, you're trying to learn how it's structured, Gremlin gives you a great amount of power to be able to do that as a novice. The trick comes in when it's time to build your application.
Yeah.
You may have written 3 or 4 traversals that answer some questions that you need to have in your application.
Okay.
And they're all separate and they're all disparate. And the trick comes when you need to collect data from all 3 or 4 at once.
Okay.
And then shape that resulting data set into something your application can actually use.
Now, are you talking about a case where you are combining the results of those traversals?
It could be that. It
Okay.
could be independently taking a very large traversal that you've managed to just walk an entire path with and then pull off specific things, then twist it into a map and remove some duplicate entries in the map and
I see,
do those kinds of things. People tend to get a little turned around when they see that. And a lot of the Gremlin that you see on our mailing list and so forth, that are answers to people's questions tend to be typically around that kind of thing. So I tried in my talk to point out this particular skill that you kind of need to develop, and I showed some examples of how you how you do those kinds of transformations using a customer 360 style use case, which seems to be a fairly common thing that people do, just judging by the questions that I see online.
I see. So it sounds like it's less about like, sometimes you can look at a Gremlin traversal, right? And depending on what it's doing, you might see this like really long thing, like, oh, that's totally advanced. But what I'm hearing is, actually, that might not be. Right. That could still be in that more novice range. It's just one with a lot of steps that is traversing far, but there's other characteristics to getting into that advanced realm, which really depend on the types of steps you're performing and how you're like manipulating the data, that kind of thing.
Yeah, and I hope I conveyed that. I hope I conveyed that in the talk a little bit, because I was trying to show, here's a big blob of a traversal. Yeah. But if you really pick it apart, and I kind of struck through the parts that were just transformative. I said, if you can understand these things, it's really just composition of novice level traversals inside of a transformation. And if you can see
that's
that,
an interesting way to look at it.
Yeah, if you can see that pattern, then all of a sudden, like, those blobs don't look like blobs anymore. And to be honest, like, everything is hard, right? Like, whatever query language we've all seen, if we've been developing software long enough, we've all seen SQL statements that are 300 lines long more, right? It's the same with it's the same thing with graph query languages. I mean, if you like Cypher, that's cool, but I almost certain I've seen some really fat Cypher statements that are 30, 40, 50 lines long. And
you can get there.
You can get there. So it's just a question of seeing the patterns and in Gremlin, understanding what those transformative steps are doing. Yeah. And then suddenly, hopefully, something will unlock in your head, and it'll make a lot of sense.
Okay.
So we talked about that part, and then I kind of built on that from there, and we talked about how to use domain-specific languages in Gremlin, which I hear a lot of people are doing. It's been really cool here at the conference, because I've been talking to users, and it's amazing how many people are actually building their applications in Gremlin with domain-specific languages.
So you're finding a lot of people are using them.
Yeah,
that's cool.
I'm very happy to hear that.
Because well, I know, I can only imagine, like, from my perspective, I know that you personally and others on your team and everything have actually done a lot of work to bring DSLs to life in the coding variants. I reckon, and there's all sorts of blog posts, there's, documentation, things that go along with that. We use them as well in our reference app, right? Yeah. And they're a really neat way to, like, abstract out the domain language, right, from my schema, my graph schema, or whatever, my app, and make it really easy to understand. Yeah. But I'll admit, it's been a little while since I've taken a look at them. So it's kind of like I have this, here's the shot when you guys first started doing this, and now. Yeah. And it sounds like they've definitely gotten some traction. People are out there using them.
Yeah, and it's not too different than the last time you looked at it. The mechanics are still pretty much the same. Right before I came to the conference, I made sure that JavaScript domain-specific languages were going to work, because that wasn't something we'd actually developed.
So
that will be there in that'll be there in this next release.
Oh, that's coming. So we could expect that in, like, Node or Node.js or any of the frameworks.
So every language variant now directly supports DSLs. You can do DSLs in earlier versions, but you have to do, like, that monkey patching stuff, which isn't as nice. But I came up with a way to kind of do it so that it's more like the Python method, which is actually really, really easy and flexible.
So we're talking then Java, C#, Python, coming in JavaScript, right? What, Ruby? Did you guys do Ruby?
No, we haven't done Ruby yet. But we've been maybe waiting for that contribution. I don't. It's one. Like, I don't know if I can. I guess I can learn another programming language. But
why not? Full stack. Full stack. Yeah. Go ahead. You got it done? It's done.
Yeah, I know.
Good job.
Right? So, but yeah, so that one's coming, and like I said, we went into some detail about more than just domain-specific languages for your application domain. Yeah. But also, you can use domain-specific languages to extend the graph domain itself, right? So to extend Gremlin itself, if there's steps you find missing in Tinkerpop, you can often implement them yourself using the DSL. And I don't know if folks always realize that.
That's a good
point.
So
I kind of made that part of the part of the talk, because I know there are some things that we haven't quite got to yet in Tinkerpop. We're slow to add steps because adding a lot of steps isn't necessarily a great thing for the community.
Right, you don't want to add any more complexity than you need to.
Exactly.
Right,
yeah.
So
that's kind of where the talk went.
Okay.
And, yeah, it was a good time.
Okay, very cool. Well, hey, thank you everybody for watching. Again, this was Stephen Mallette, like I said, the graph development extraordinaire. I don't know if that's an official title, but that's okay. And we appreciate you checking out Accelerate Live.